Hi guys, and welcome to Monday, November 9th. I have created this video to go over the worksheet that I gave you in class. And what I did was I completed them myself and then took a picture of them. And so I've put that on here and I'll work through how I solved them. You may have come up with something different, and if yours makes sense and you were able to defend it, then you don't necessarily need to change it. The main thing here is that you are looking for definitions, theorems, postulates that support what you are doing. And a lot of times, you'll forget things that were given, or you'll forget basic definitions, and those can be used. So let's go ahead and get started. We're going to take a look at proof number 1. And what I've done is I've reposted the diagram with the given information, and then I've posted my answers and I will talk you through them. So in this one, it tells us that angle 2 right here is congruent with angle 3 right here. Now, if I had a nice little whiteboard, I would make congruent signs just to remind me that 2 and 3 are equal. Then angle 1 is congruent with angle 4. So what they want us to prove is that ABE is congruent to CBE. Now I always put that last. And I don't know if I'm going to need 7 points to prove it, but I do go ahead and put it in there, and then I go back and I do all my givens. So I'm going to go ahead and put in here that angle 2 is congruent to 3, and that's given. Angle 1 is congruent to 4, and that's given. Even if you do not know what you are doing and have no idea how to solve a proof, if you set something up with the givens and then what the conclusion is, you're going to get some points. But to completely leave it blank is not a good thing. Now the next thing that I've done is, since I know that 2 and 3 are equal and 1 and 4 are equal, I can put some things together. So angle 1 plus angle 2 is congruent or equal to angle 3 plus angle 4. Now what I'm using here is substitution. You could also use addition. You could also use probably something with linear pair, but I felt like it was easier just to put in substitution. I don't have any numbers yet, and that's not necessarily what I'm going to be able to find out, although I do know that this is a straight, well, I don't know that this is a straight line. I'm going to make some assumptions, but I don't need any numbers here, so I don't really need to go through that. If you notice, they begin by talking about angle 2, angle 3, angle 1, and angle 4. But by the end, they have moved to letters. Angle ABE equals angle CBE. So at some point, we have to start moving toward that. So what I'm going to do is I'm going to take angle 1 plus angle 2 equals ABE. That's pretty much given from this information, but I'm going to just put substitution because I'm substituting ABE in for 3 and 4. Then I'm going to do angle 3 and 4 are equal to angle CBE. Again, it's pretty much given in the information that we have up here. There's just a whole bunch of different things you could use. You can use substitution, and you can use given, because we know from up here that they are the angle numbers, the angle letters. And so you could put substitution, or you could put given in there. Then I am going to go ahead and boldly say that ABE equals CBE. Now, if I had lined all of these up and started to take out the 1 and the 2 and the 3 and the 4, it could be subtraction. Again, it could be substitution. I'm just substituting these letters in for these numbers. So I know these are really hard, but substitution is one you're going to use a lot. The addition, subtraction, multiplication, and division ones are one you are going to use a lot. Given is something you're going to use a lot. Most of this information in this proof could have actually come from what we were given. The other thing to remember here is that we moved from angle numbers to angle letters, so that had to be part of the logic of your proof. Okay, let's move to number 2. I'm given that angle MON, or given line MON, excuse me, and then the measure of angle NOP is 125. Now this is a line. That means it's a straight line. It can't be a line if it's not straight. That means a 180 degrees. So there's some things that I can assume here. Then they told me that NOP equals 125, but now I have to prove that this equals 55. So let's get started. I'm going to put down that the measure of NOP equals 125. That was given. Then I'm going to say that NOP plus POM equals 180, and that's the definition of a linear pair. Then I'm going to say that 180 minus POM, or MOP, I guess is what it is, equals 55. Finally, I'm going to say that the measure of angle MOP equals 55. So here, the second one was just the linear pair, NOP, POM, or MOP, whichever, equals 180 degrees. That's a linear pair definition. But then if I take the 180 minus the POM or the MOP, which they told me is 55, I could do subtraction. I could probably get away with given there. And then finally, I'm left with the angle of MOP equals 55. That could be substitution, it could be subtraction, it could probably be definition of a linear pair. Any of those would justify. So this one was pretty easy. There were only a couple of steps. But the key thing was identifying the linear pair, because they did tell us we have a line. We had the measure of one. We just had to find the measure of the other. Okay, proof 3. In the figure, angle 1 and angle 4 form a linear pair. 3 plus 1 is 180 degrees. So they tell us that 1 and 4 form a linear pair. They don't tell us that 2 and 3 do. But they do tell us that angle 3 plus angle 1 equals 180 degrees. They want us to prove that 3 and 4 are congruent. Okay, so I'm going to start with my basic. 1 and 4 are a linear pair. That was given. Then they actually gave us reasons, and they said angle 1 and angle 4 are supplementary, and I just wrote in there 180 degrees. That just means the definition of the linear pair. Then they had that, oh, I can't even read this, measure of angle 3 minus the measure of angle 1 equals, or must be plus, equals 180 degrees. And I put substitution there, but I think probably the better is given, because they give you that. So up here, it's given. Then angle 3 and angle 1 are supplementary. And what I did here, angle 3 and angle 1 are supplementary. That's a definition. Given or definition actually would go toward the definition of supplementary. Then I put in an additional step. Angle 1, because I wanted you to be able to see this. Angle 1 plus angle 4 equals angle 3 plus angle 1. And there I'm putting in substitution, but then I'm going to subtract. So I'm going to subtract out the angle 1, and the angle 1. And then I get that angle 3 and angle 4 are congruent. So I think I'm not sure if they missed a step in here, if I just added something unnecessary. But we do know that angle 3 and angle 1 are supplementary because of the definition. Supplementary means 180 degrees. But then I wanted to put something in there that I could subtract out the angle 1s, and there's the subtraction, and be left with it. They are congruent. Hopefully that made sense. All right, number 4. They tell us that angle 1 right here is congruent with angle 4 right there. So I put that in with my given. Remember, I pop all the way to the end and go ahead and put what I have to prove. Here's my given. All right, then I am going to say that angle 1 equals angle 2. Why did I say that? Because of vertical angles. Then I'm going to say that angle 4 equals angle 3. Again, vertical angles. And now I can say that angle 2 equals angle 3. And that could be transitive. So I have, if you think of the word transitive, it's like moving something in that direction. Or I could use subtraction. I would have subtracted out 1 and 4 from these, or from 2 and 3. So I'm left with angle 2 equals angle 3. So there's a couple of things that you could use there to prove that. All right, number 5. Now, it really helps if you guys have your index cards in front of you, because then you can flip back and see what can support your theories. All right, angle 1 is congruent to angle 3. Here we go. Angle 1, angle 3. That's congruent. Now, there's another piece of given information in here, and that's I've got right angles. And so, while it's not written up here, I can use it as given because they've made the mark in the diagram. So down here, I put that angle 1 plus angle 2 equals 90 degrees. I know that this whole thing equals 90 degrees. This is a right angle. So I can put given, or I can put given right angle measurement if I want to clarify that. I also do the same thing over here. Angle 3 plus angle 4 equals 90 degrees. And again, it's given because they drew it in. They didn't say it up here, but they drew it in. But it is given, or I could put measurement of a right angle. Now what I'm going to do is I'm going to take this 90 and I'm going to get rid of it. And I'm going to do the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. I had 90s right here. So now I'm substituting these in for the 90s. 90 equals 90, so these should be equal to each other. And then I am going to get rid of, and you notice I made some little marks here because I know that angle 1 and angle 3 are equal. I can get rid of them. They're the same thing, I can get rid of them. And then I'm left with angle 2 equals angle 4, subtraction or transitive property. Transitive probably a little less. I like the subtraction better just because you pull this out. All right, let's move on to proof number 6. AEC, this guy right here, is a right angle. BED is a right angle. Prove that AEB equals DEC. Okay, now this one's harder to see, and in my diagram, which I didn't put up here, I put a little box here to represent the right angle for AEC, and I put a little box to represent BED. So let's go ahead and get started. AEC is a right angle, given. BED is a right angle, given. Now I'm going to say that AEC and the measure of BED are 90 degrees. That's a definition of a right angle. Then AEB plus EBC equals 90 degrees. AEB plus BEC. Now that's going to be a definition of a right angle, and there is also, and I can't remember if it's a theorem or a postulate, that talks about if there are two angles in a 90-degree angle when they're added together, or if there are two angles in a right angle when they're added together, they will equal 90 degrees. But I'm just going with the definition of the right angle. Then I did the same thing, DEC plus CEB, or BEC, however you put it, equals 90 degrees. Same thing. Now I'm going to start doing what I did on that previous proof. I put AEB plus EBC equals DEC plus EBC. So I'm taking out the 90s and putting these in to equal each other. That's substitution. Then I can get rid of the EBC and the EBC, and I'm left with AEB is congruent DEC, and that would be subtraction. So that one is a little bit more clear-cut than some of the others have been. All right, now we are moving to proof number 7. We have 3 lines cutting, there's one common point, and we are told that the line GE bisects DGF. Here's DGF, and GE is bisecting that. We know then, because of that 2 and 3 are equal, so you could put little congruent marks there. I like to mark up my diagram. And then we want to prove that angle 1 equals angle 2. All right, GE bisects angle DGF. Given. Angle 2 equals angle 3. Angle bisector definition, or whatever the theorem number is. I prefer that you actually write out what you know there. Angle 1 equals angle 3. Vertical angles. I think that's the first time this has popped in here. But the vertical angles will allow us to make that assumption that 1 and 3 are equal. And then I can say, now I didn't write this all out in a nice neat subtraction thing, but I could have written out something like, let's see. Well, no, I don't think I could have written out anything there. But now what I can do is I can pull these 3's out, and I can say that angle 1 equals angle 2, or is congruent to, and that would either be substitution, and this is what I was just talking about a minute ago. I could have set up some problem and subtracted it out so that angle 1 equaled angle 2. All right, on to proof 8. I'm given that angle 3 equals angle 4. I want to prove that the angle 1 is equal or congruent to angle 2. All right, here we go. Angle 3 and angle 4, given. You should get points for that automatically for putting it in. Then I am going to put here that angle 1 plus angle 3 equals 180 degrees, and that would be linear pair. Now, I could have put a step in there to say that angle 1 and angle 3 were a linear pair, and then I could have said that they were 180 degrees. And I'm going to also do the same with angle 4 and angle 2, 180 degrees linear pair, or definition, or measurement, whichever you wanted to put it there. Now I'm going to take these 180 degrees out, and I'm going to set them equal to each other. Angle 1 plus angle 3 equals angle 4 plus angle 2. Substitution. Just substituting them in for the 180. And now because I know that angle 3 and angle 4 are equal, I'm going to get rid of them. I'm subtracting them out. I'm left with angle 1 equals angle 2. Now I didn't put measure, I didn't put M in here. Some of those had them, some of those don't. As long as you've got the angle mark there, I'm okay with that. All right, let's move on to proof 9. Now these were just line segments. Some of you tried to measure these on the test, and we don't necessarily want to measure them because what we want to find out is the answers from the information we have. So it says find the value of the variable, that would be n, using the given information, and provide a reason for each step. So QR equals RS, QR equals RS, and ST equals RS. So I'm going to start with the first one, QR equals RS given. ST equals RS given. That then means that QR can equal ST, and that would be substitution. You could even pull off subtraction there. Then, since I know that they are equal, I am going to put 5n equals minus 2 equals 23. Now, I put given there, but I think it would be better to put substitution. So given or substitution would be okay. Then I do my algebra. I added 2 and added 2. That's addition. Then I come out with 5n equals 25. I divide by the 5, which is division, and I'm left with n equals 5. That's what they asked me to find. They wanted me to find the value of the variable. So this is similar to a proof, but you're actually doing an algebra problem most of the way through. And then finally, the last one, this is similar. Find the value of the variable. AB equals BC and BC equals CD. So I'm going to put AB equals BC given, BC equals CD given. Then I do the same thing, AB equals CD, and that's just substitution or subtraction, whichever one you did. Then I'm going to do the 3t plus 1 equals 7. Again, substitution, because I'm substituting this in for the name of the segment. I do my algebra, 3t equals 6, because I subtracted a 1 there, subtracted it there. That would be subtraction, and then t equals 2, that would be division. This is my value. So hopefully this has been helpful for you. I have uploaded the PowerPoint to Documents, as well as putting this video up there. So if you just wanted to go slide by slide and look at that a little bit more. Sorry, my work is not as neat as I demand my students' work to be, but I will do that better. I was just creating a key, so it wasn't very neat, but in the future I will be neater, anticipating using these for PowerPoints. If you have questions, please bring them to class on Wednesday, and I will see you then.